Bismillahirrahmanirrahim. Assalamu alaikum dear students. I am Mr. Fadil Khan and I am a lecturer in the Institute of Computing, Guwahati University of Science and Technology. Today we will take lecture number 16 of the subject of object-oriented analysis and design, in which we will discuss the object diagram, which is the structure model of the projects through the UML. Dear students, in the previous lectures we have discussed the class diagram. The class diagram has the complete description about the data members and member function, while in the object diagram we provides the instances of the classes, and also we do not provide any information about the functions of the classes. So in the object diagram we have no information about the methods that are implemented or they are accessed through the objects, and also the informations are the state of the object is decided on the runtime. So in the class diagram we provide the full designing of the object-oriented system, while in the object diagram we provide the state of the object at runtime. This is the discussion agenda. It contains the topics of the UML object diagram, difference between object and class diagrams. Then we have the notations used in the object diagram, class diagrams to object diagram. Here we will provide you information about the convergence of the class diagram to object diagram. Then we have the usage of object diagram. That means that where we can use the object diagram. Now, what is the object diagram in the UML? Basically, as we know that object is the instance of a class. Object represents a class. So, an object is an instance of the class in such a way that it represents the runtime state of the class. Runtime states mean that at the particular unit of time how the state of the class will be, and that will be represented by the object. So every object has its own state or the data values. State means that at the runtime or at the particular unit of time, what will be the state of the object and what sort of data will be contained in the object. So the object diagram shows the state of the system at the point in the time. That means that in the particular time, what should be the state of the objects when the particular object is called and when the object has a particular state at that time. Thus, an object diagram has the objects and the relationship which may be considered a special case of a class diagram or a communication diagram. Because there is the element of the time, so that's why it is also a representative of the communication diagram of the UML as well. And also it is as a special case of the class diagram too. Now, the object diagram depicts the behavior. Behavior means the functionality. When we have instantiated it. So when we instantiate the objects, it gives us a particular behavior. So here we provide a behavior of the system at the particular instant. At the particular instant means that when we instant or when we create the objects, then it contains the particular behavior. For example, one time I call first function of the class and second time I call the second function, then the state of the object will be changed at runtime. So object diagram portrays the functional requirements of the system. So all the object diagram that gives us the functionality of the system, which is the requirement specification of the project. Now, what should be or what is the difference between the object diagram and the class diagram? Dear student, first you look at here. This is one of the class of the bank account, and there are two attributes in the bank account: the public balance, which is of the data type of long integer, and the public account valid till, and it is of the data type of the date integer. And there are two functions of the public access specifier. Withdraw, it provides us the bool, or it returns the bool value, and show balance, it returns the long integer value. This is a class, while this one is the object. You can see it is the bank account class, and account 1 is the object which is instantiated from the bank account. Now, when this is instantiated, then balance 12,500, it will give us the balance. Now you can see the balance is the variable or the data member here, and it is of the long integer value. So at runtime it will give us the 12,500 in the balance variable, and account valid till plus field type. So it will gives us the account valid till date, and it's is the field type. Field type means that it has been provided. It gives us the output in the field in a particular text boxes, etc. So this is an object. You can see there is no functions. So just we have called a particular functions here, and it has given two different values. Now here in the text we have provided the difference between these two classes. This is one of the class and this is the object. So object diagram is similar to a class diagram, except it has the instances of the class. You can see this account 1 is the instance of the bank account, and this is the bank account class diagram. Well, this is the object diagram. Account 1 is the instance of the bank account, and this is the column operator which gives us the instance of the objects from this particular account, this particular class. Now we depict actual classifiers. Here this is the actual classifier, and the relationship between the among the use of the class diagram. This is the classifier. Classifier means class name, and this is the object name, which shows the relationship between this object to this classifier. While in object diagram, it represents specific instance of a class. Here you can see this is the instance of class and the relationship between at that particular time. That particular time means that when a particular point of the time, this will be the state of the object. Now we are here explaining different sort of the notations that are used in the object diagram. First one, objects are instance specification. When we instantiate a classifier in a system, then we create the objects here, which represents an entity which exists in the system. So that means this is the entity which exists in the system. We use this rectangular shape, a rectangular icon or a rectangle to represent an object in the object diagram. And here we will provide all sort of the attributes. This is the representation of the object. Now, for example, here you can see that this is an object class college A, which is the instantiated from the college class, and there are the attributes: number of students in the college 1200, and city A is the city where this college is existing. Number of departments, there are 9 departments. Faculty strength 130 is the faculty strength. Now this is another object which is instantiated from this object. That means that in this figure, two object class students are linked to an object of this class. Now here student number 3030, and it is instantiated from a student class. Name is A, department is CSE, computer software engineering department, and it is 4 years students. And this is students 3040 students, and student name is B, and it is after computer software engineering class, and it is here number 3 student. So there you can see there are two different objects which are instantiated from this object. So that means that we can also instantiate object from another object. and this is the symbol which represents an arrow, a line which represents the association between two different classes. So this is the association here among two different objects. Now links. This links is used for the association, which is a relationship between two classifiers, and the links is used to specify relations between two instances or specification of the objects. We use a solid lines to represent a link between two objects, and the association means that when we instantiate an object, then the association relationship is established. So the straight line represents the association. Now on the every association we provide certain notations, and this notation represents the number of objects declared. So we use links to represent a relationship between objects. So how many objects we can declare? 0.1 means that 0 are one instance. They mean that we cannot create, we do not require any object creation, or we must have to create only one object. Here we mean that only one object can be created. 0 to star x means that 0 or more, multiple, infinite objects can be created. Here it means that on infinite objects can be created, but it cannot be, it should be 0 or more. It is exactly like above. You can say 0 to multiple or simply only multiple. 1 to multiple means 1 or more objects can be created. 7 means exactly 7 objects can be created. 0 to 2 means 0 or 2 objects can be created, and 4 to 7 means 4 to 7 objects can be created. Now this symbol represents the dependency relationships. Dependency relationship shows that one object is depending on another. Here we will provide the certain stereotypes of the user's relationship. Then this object is using another object. This is called the dependency. So in class diagram, component diagrams, deployment diagram, and in object diagram we use this dependency relationships. And the dependency relationship is very much important, that one item or one object is depending on the another object. They have certain dependency. So when one object is changed, the another object will also be changed. So that means the structure of one element, when some changes occur in that structure, the another element will be affected. So this is the unidirectional kind of relationship between two objects. The dependency relationships has different types with the keywords, and the keywords are provided in the annual brackets. For example, we provide here the abstraction, the binding, realization, substitution, and our usage relationship. These are the certain relationships in the UML. For example, uses means that one object is using another object. Abstraction means that the objects are declared abstractly. So we can use only abstracts, for example, like the abstract data type. Binding means that at runtime, when one changes will be changed, then it can be changed here, like the late binding or early binding and compile time binding. Dynamic binding similarly. Realization means that one object is realizes that it existing is there. So the realization means that, for example, we realizes the interfaces, like that this interface is realizing or it is using the another component. Substitution means that this object is the part of another object, or it is substituted here. Now here is an example of the uses relationship. The uses relationship shows that one object is depending on another. For example, Mango's object is depending on player 1 object. You can see that in the player 1 object we have abstractly defined the sports, cricket, gender, male, and age 23. Now mongoose is in a particular player. For example, here we can provide a player name and he can bat. He is instantiated from the bat class and the weight of the player is 1.25 kg, means that bat weight is 1.25 kg, height is 78 centimeter and width is 2 inches. Now that means that mongoose which is instantiated from the bed, if we change the bed, automatically changes will occur here. For example, if we here change another types of bed which is different than the mongoose, then these specification will be changed. That means this is depending on this. When this is depending, means that all information is depending, then the player 1 is also depending on mongoose bed. So that means this class is depending on this class. The another relationship is called association. It is a unary associations are between two different objects. Whenever one object uses another, it is called an association. So we use association when one object references the members of the other objects. So association can be unidirectional or the bidirectional. This is the unidirectional association. That means that only information will be flow from one side to another side, not from the bidirectional. We use the arrows to represent this association. This is the examples of the associations here, which is of the one directional. So here the order class is associated with an object of the customer class. There is the customer 201 and this is the order 101. So that means that 101 is associated with 201. Customer 2, this is the order and this is the customers. Another example is another types of relationship that is called the aggregation. Aggregation has a relationship. Like we says that student has a GPA. So aggregation is a special form of the association. It is an association which represents a part whole or a part of a relationship between two different objects. So here it is a child relationship, but it is not an inheritance. So the association is exactly like the parent-child relationship, but it is not an inheritance, because in the inheritance the child is the full part of the parent, but in the aggregation it is a part whole or a part of a relationship. That means that it can be a simple part of a parent's class. So aggregation occurs when the life cycle of the contained objects doesn't strongly depends on the life cycle of the container objects. So here the one object is not fully dependent on another, but it is partially dependent. Here it is the example. This is lab1 is the object of the library and the library location is A and books in the library are 2100. Now book number 201 is instantiated from the book class and its title is Concepts of Physics. Author is H.C. Vermas and the page number, total pages are 502. So you can see here this is an aggregation of with the lab1. That means that this is the part of the lab1 library and its location A and number of books in these libraries are 2100 and this is one of the books in this library. So this is one part of the full library. This book is the part of this library. So this is called the aggregation. Now how we can convert a class diagrams to object diagram? This is an example of a class diagram. Here you can see that customers is associated with order. So one customer can post or can provide one to many orders. Similarly, many orders many orders can be posted by the customers. So means that customers order for one or more items here. Now the orders has normal orders and special order. There are two childs of order class. You can see normal order and special orders. This is like generalization relationship, which is the inheritance, and these two are the subclasses of the order class. Order is the parent of these two child classes. If we convert this class diagram into the object diagram, this will be the output. So here on the top we have the customers class and C is the object. C is instantiated from the customer. Now then we have the O1 which is instantiated from the order 1, then O2 another order instantiated from the order class, O3 is instantiated from the order class. So order number 1, number 1200, order number 2 which is the number 61, and order number 3 which has the order number 88. Now S1 special orders number 43. This is the special orders, and this is another special order. This is another special order. Now it means that here you can see that the execution of the particular unit of time has this sequence, that first customers object is created, then the order object is created, and then the special object order is created. So here we have three different orders for the special orders. So that's why there are three different classes, and all of them has the association relationships, not the generalization or the inheritance relationship. This is the difference between class diagram to object diagram in particular unit of time. This is the particular unit of time when these orders are executed, or these orders are in fact done by the customers. Another example, it is little bit simple one, that we have the writer class. There are two attributes of the writer class, name and age, or data types strings and integer respectively. Then we have the document class of the types name, strings, and page number in number of pages of that particular document. And this is the association relationship. Association relationships means that this is as a binary association relationship, means that the object of the document class can be accessed here in the writer class, while the object of the writer class can be accessed here in the document class. Now, at the particular unit of time, when we create the object diagram, this will be look like this one. So here, writer Ethel is the writer object of the writer class, and draft is the object of the document. So either name equal J Albro and age is 34, while name of the draft is all about me temp, and page number is 34. So and master document master, it is another object instantiated from the document class, name all about me and page number 28. So you can see there are two different objects, draft and masters, instantiated from document classes, and they have at the particular unit of time different values of these two data members, and these are associated with one class, ether writer name ether J Albro is 34. Now where we can use the object diagram, it is used to model the static design, but it is similar to the class diagram or a structure of system using prototype instances and real data. Here we can prototype the instances of the classes, and also we can provide the real data at the particular execution time of the object. So that's why it is the structure that provides us the structure of the system, and it is the prototypical structure of the system at the particular instances and the values at that particular time. It helps us to understand the functionality that that the system should deliver to the user. It gives us full view about what sort of functionality the system is providing, because when we provides awareness to the customers that this will be the output and this will be the input and this will be then output. So the customers in fact gain here full understandability about the functionalities of the system. Understand relationship between the objects. Here we understand different sort of the relationships, such as the aggregation and similarly encapsulation, similarly the usage relationships. So all these relationships can be obtained from the object diagram. It gives us visualized, documented constructs and the designs of the static frameworks of the instances of the objects, and also it gives us the relationships in the dynamic story of the life of the system at the particular runtime. So when all the informations are provided in the format of the visual layouts, and also it gives us full documented view and the designs of the static frameworks of the system, but it will give us the information at the particular unit of time about the execution time. So this will give you a good concept about the problem. It also verifies the class diagram for the completeness and accuracy by using the object diagram as specific test cases. So all the test cases that we are going to execute or to test the software, it gives us also an example of the test cases, because when we provide the input, it gives us the output. So this one shows us that what will be the input output here. Also, it describes the facts and dependencies between specific instances and depending specific examples of the classifiers. All the dependencies that one object is depending on another object, then it gives us good view about the dependency as well. The dependency is provided through the uses stereotypes in the UML object diagram. When we have certain dependency that existing of one object is depending on another, then one object is changed, or if it is removed from the object diagram, then another object will also be dependent. This can be in fact obtained, this dependency is only obtained in the object diagram as well, like the class diagram. Okay, dear students, this is the end of the lecture. If you have any questions, you can drop an email to my email address, that is n.kadim@kust.edu.pk, and you can study these two books for these topics. For example, UML2 and Unified Process Practical Object-Oriented Analysis and Design, International Economy Edition paper book. This is very much a useful book for the UML2. Also, we have this UML Distill, a brief guide to the standard object modeling language by Martin Fowler per Beck. This is another very good book. If you have again any question, you can email me and I will wait for your response. Thank you very much.